This is a compass. It's just like any other compass. It's got orienting lines, a ruler, a rotating bezel, and a magnetized needle. But do you know what the most frustrating thing is about a compass? It only points north. But what if there was a compass that could point to something way cooler? Like, I don't know, the nearest slice of pizza. So that's my challenge. Wired has given me 3 weeks to figure out how to turn a regular compass into a compass that points to pizza. It's beautiful if I say so myself. Oh, this is so cool. It's actually working. To the pizza! By the way, I'm Joe Grand. I'm a computer engineer, hardware hacker, and former technological juvenile delinquent. I built my first circuit board when I was 10 years old, and I just love doing this stuff. Successful. So there's a few goals for this project. The most important one is to actually build a system that no matter where I am in the world, it's gonna point me to the nearest pizza place. The second goal is to take our mess of wires and components and refine that into something much smaller, more like an actual compass that we can just walk around and use. The third goal is to make this thing as simple as possible. So you just push a button and you follow the LEDs. There's two separate design aspects for this project, the hardware and the software. The core of the project is this little module made by Particle. It's a microcontroller module and a cellular network interface module in one. This is going to control all the other peripherals in our design and also let us communicate to the internet over the cellular phone network to get the information that we need to point us in the right direction. We have our antenna. The next piece is our GPS module. GPS is pretty common these days. It exists in all sorts of different devices, like in your cell phone, which is probably how you're being tracked right now. The next thing is a magnetometer. This is a digital compass. So it's gonna measure the magnetic field of the Earth and tell me my heading. Next we have our LED indicators. Of course, no electronic product would be complete without a way to power it. So we have a small lithium-ion battery. Oh, I didn't put a button, but whatever. Maybe I should get a button. How can I forget about the button? Do I want laser, missile, or top secret? I'm gonna go with top secret. So this board here is called a breadboard. It's basically a little board where you can plug components into it. So it just makes it really easy that when you're prototyping, you can take parts in and out as you need to kind of get stuff working. I have these individual components all plugged into the breadboard and wired up, at least in an initial configuration. I'm not exactly sure how things are gonna go once I start writing the code, but this at least is gonna let me get started. Now I'm gonna go take it over to my other desk and start working on the code. But first, hold on, I gotta hack into the Gibson, move the satellites around, and you're done. So my plan now is to work on the code and try to get each of the individual components operating. So I basically have some sample code that I'm using from the open source community, so code that other people have written to support different modules, taking that, kind of modifying it, tweaking it for what I need, and just making sure that I can communicate with each thing at a low level. Error. That's usually not good. All right, we finally have some progress. LEDs turn on, let go of the button, LEDs turn off. So I have the LED ring working, I have the button working. Now I need to get the compass working and the GPS working and then the cellular connectivity working so I can communicate to the internet over my microcontroller. I am still working on some code to get the compass module working. I have a little debug terminal over here too, so I can send messages from my microcontroller to the screen so I can actually see like what state of the system are we in. So right now it's just waiting for a button press. So when I go and hit the button press, the system should start doing some setup. All right, welcome to Pizza Compass. The LEDs turn blue just so we know that we're in a different state. When I let go of the button, the calibration will stop. Let go of that. And now we can see X, Y, and Z values in micro Tesla. These are basically just readings from the sensor of the magnetic field that it's reading. So if we actually spin the unit around, we can see those values change. Now those values don't really mean much to us right now, but what we're gonna do is, along with our calibration values, calculate the actual heading of this compass. You know, which direction is this compass facing? Taking boring numbers like that and turning it into something useful, and then we're gonna try to display that as an LED on this ring. Code. So just taking some baby steps here. I added some code to take the compass information and convert it from the magnetic sensor data into an actual compass heading. And we can see down in our little terminal window over here that right now it's about 50 degrees. If I rotate my board in a circle, that's going to change the heading. I wish this was more exciting. Reminds me of the story when, well, I won't tell you that one. So this is pretty cool. I now took the heading that we were getting, basically divided it by a 360-degree circle to figure out which of the 24 LEDs on our ring should be lit up. As I rotate this board, the LED stays in the same position. So it's maintaining its heading no matter which way we're pointing. Sort of like an actual compass. Compass code complete. Onto the GPS. I know that the hardware already communicates properly to this particle cloud service, but what I haven't figured out yet is how I can send a query with our GPS coordinates over the network to get the information back about the nearest pizza place. Here's what I'm thinking. I'm gonna push a button on the compass. That's gonna send my local coordinates over the cellular network to Particle. Particle is gonna take that, send it as a search query to Google with my coordinates and asking for the nearest pizza place. Google is gonna respond with that information, send that back to me. I'm gonna process it, and that's gonna point us to pizza, hopefully, because I'm hungry. It's kind of funny because being a kind of paranoid old school hacker, I tend to avoid Google services as much as I can. But in this case, Google just ended up having the best results that we need. You know, they offer their API to basically let developers and let engineers and let people use their technology and use their search engines without having to physically type stuff in. They're kind of just contributing to this general collection of Internet of Things and this general collection of cloud-based intelligent computing. So it's the Google Maps platform text search. It's a certain service you can sign up for with Google, so I just logged into Google, signed up for the API. All you basically are doing is passing in a query. I put pizza. Of course, you could change that to anything else you want because it's Google. And then the location, so you'll pass in the GPS coordinates that, of course, we've captured with our GPS module. And then the key, which is your own private API key that ties this request to your particular account. So, of course, pretty much all of this is going to have to be blurred out. But if I go and paste this into a web browser, it's gonna go to Google, query from Google, and get back in a JSON format all of the search results. So this is basically, given my location, searching for pizza, what's around me. A lot of information is transferred behind the scenes that we never see over the internet. It is in formats like this, which is kind of cool. Latitude and longitude, that's what we're gonna end up grabbing from this entire blob of information. That's what we want to use. So let's go ahead and press the button. If we look on our screen, we can actually see sending request. So we are formulating a packet that we need to send over to the Particle cloud, and then Particle sends it to Google. So it's sending with our coordinates along with some of the other information that it needs. There's a whole kind of packet structure that we have to send over to Google. We already see data received. So it went over the network to Particle, to Google, back to Particle, back to us. We can see here GPS coordinates, and then the name of the pizza place, which is Sonny's Pizza. That's one of the few pizza places that are around my house. Now that we have that, we can continue to take those coordinates, feed it into the algorithm that has to figure out the point-to-point location and direction and all of that. But the fact that we can send data and formulate the packet that we need and then get information back is pretty awesome. I'm super excited about that. A circuit board is really a physical manifestation of an electronic product. It physically holds the components onto the board, but then it also provides the electrical connectivity between all of the components. Designing circuit boards is really like creating art. And it actually is called artwork when you create the circuit boards. That's the technical term, is the circuit board artwork. Most of the time though, circuit boards are inside of products, they're not seen, so they're really designed and manufactured to fit into an enclosure, to be easily tested, to make it easy to assemble. They're not really worried about aesthetics and how it looks. But that's something where a lot of the stuff that I work on, I don't put it in a housing. I have the circuitry exposed. I want it to look not really like a circuit, but more of a piece of the larger project. So I don't want it to just look like a piece of electronics. I spend a lot of time in the circuit board design tool, which is not intended to work really with graphics at all, to try to make products that look cool. And it takes a lot of time, takes a lot of tweaking and trial and error to bring in graphics and adjust them and kind of fit well with the actual required electrical connections. But that's really, to me, is what's so satisfying about creating a board, is you put in all this effort into essentially a piece of art, and you can express yourself in different ways through that medium and get something back. So it's a very kind of special, sacred process to work on circuit boards. So here's a rendering from the circuit board design tool. This is the front side of the board. I had added the artwork, so now we have all these artistic elements. We want it to look more like a compass. So we have the ruler, we have our compass rose down here. This is all gonna show up as immersion gold. So this is gonna be gold plated. The GPS is gonna go here, the button's gonna go here, the LEDs will go here, the magnetometer right there in the middle, and then the backside will have the other circuitry. I thought that looks pretty close to an actual compass, especially with the ruler on here and everything. I'm super excited. As far as production manufacturing of circuit boards, there are hundreds of manufacturing facilities around the world that will manufacture your circuit boards. You basically provide them with a bunch of design files called Gerber plots, which is kind of a text representation of your entire circuit board design. So I'm gonna have a professionally manufactured circuit board and then have it professionally assembled as well. I might need to do some touch-up hand soldering, but if everything goes well, it's gonna be manufactured and assembled by machine and then sent back to me. The first step is the raw material selection. Then it's time for drilling. The drilled panels are coated with a resist. Those panels are then taken to a laser plotter, which burns an image into the resist film. Then those panels are placed into a special rinse that removes all of the laser burned portions, leaving only the design that I specified. For electroplating, the boards are put into special pulse plating tanks. The exposed copper and the drilled vias are going to be plated, which gives us the copper connections. The next step is to etch off the copper that was previously protected by the resist film. That leaves only the copper traces on the top and bottom layers that I've designed. The solder mask is the black coating that I've specified on my board. They place the circuit board panels onto a screen printer, similar to how a t-shirt is made. The assembly process is a little less complicated, but there's still a number of steps. Once the solder paste is applied, the boards then go to the pick and place machine. The pick and place machine takes all of the parts and places them exactly where they need to go on the circuit board. They then go into a reflow oven. It's sort of like a giant cookie machine. The boards go in, follows a very specific heating profile, and it comes out at the end, a freshly baked circuit board. After the boards pass the 3D X-ray, they go to AOI, Automated Optical Inspection. This time the operator is looking at all the components, making sure they are soldered down properly, nothing sticking up, just to get that final last step before the boards are cleaned and sent on their way. For our board, we need to go through an additional assembly step because the GPS module can't go through the wash, so it has to be hand soldered. There's a pretty clear difference between the parts that I use for the prototype and the parts that I use for an actual production circuit board build. The main difference there is for the prototype I was using little modules, sort of development boards that are intended to make it easy to connect to a prototyping board like we did, run wires to it, test all the different features, but I don't need all of this stuff around it. What I'm using for the production build is just the actual component itself. There are some additional components I need for it, but I don't need that giant board with all the pins and everything. So basically moving from modules that are designed for development into using the individual components intended to be mounted directly onto a circuit board. I heard a knock on the door. The package is here. This is it, right here. And spare components on the bottom. Oh, I am nervous. So many layers, it's like peeling an onion. So far, so good. Holy moly. Oh, that looks so cool. Oh, man. So the compass in the middle, the LEDs along the side, our button to start our quest and send the data over the internet, our GPS module, our ruler in case we need to measure things. Here is the connector for the particle board, some of the discrete components, and all the traces are on the backside. Assembled pizza compass board is done. We have 3 of them just in case something goes wrong with 1 or 2, but it looks amazing. I can't believe how fast we got these things back. We're good to go. Fingers crossed, ready to give this a try.
It's been 3 weeks since I started the design, and today is the final test. Let's go find some pizza. Let's power this thing up, plugging it in. All right, so first thing we're gonna see is the LEDs initializing so we can make sure they work. Now we're waiting for the connection to the particle network. The green is looking for a GPS fix. So now we're in the next state, which is that the compass is ready for calibration. I'm gonna hold the button down and all the lights will turn on. So now we're in the calibration mode where we need to rotate the board in all of the different axes in order for the magnetometer to read all of the different values. So we do it in the X, in the Y, in the Z. So we push the button to exit calibration. Now we're in our rainbow color wheel. This is just waiting for us to push the button to start our quest over to the pizza place. Sending the coordinates, waiting for a response. And now pointing to pizza. So let's see where this takes us. So I think I have to go that way. I just reached my first intersection and the compass is pointing as the crow flies. So unless I want to walk through a whole bunch of backyards, I need to follow the roads. So it looks like I need to go right down here. I can tell we're getting close because the compass starting to veer off of the straight and point more towards the left. So I think this next block up here, I'm gonna turn left. Oh, this is so cool. It's actually working. Let's turn left. Now we see green light pointing straight ahead. We made it to the pizza place. The compass works. Let's eat. Oh, thank you, pizza. I've been waiting 3 weeks for this pizza. Oh, look at that.
So there you go. That's the pizza compass. Yes, it's a little bit cheesy. Yes, there's other ways to reach the same conclusion, but that's the beauty of engineering, taking something that's in your head and turning it into reality. My real reason for doing projects like this is to put them out in the world and see what people do with them. The project is fully open source, so you can look at the hardware design, you can modify the code to do whatever you want. This is just my interpretation of what a pizza compass can do. You can refine it to do whatever you want. Maybe change the LEDs for different animations, change the battery consumption to make it last longer, or even have it point somewhere different. The point is, you can learn from it and do whatever you want with it. This project wouldn't have been possible so quickly without the contributions of the open source community. People who designed the software libraries, people who worked on the hardware modules. If I had to do all of that from scratch, it would have taken me a few months of effort, if not more. Let me know what you think about the project in the comments below. What would you point it to?